Hello everyone, I am Dr. Dhubajyoti Mondol and my channel name is Topics in Chemistry. Please subscribe my channel. I will discuss different topics of chemistry in this channel, so please subscribe my channel to get latest notification. Today our topic name is phase diagram of sulfur. This is another one component system. So in my last two lecture I told you what is the phase diagram of water and phase diagram of carbon dioxide. So now you have to know what is the phase diagram of sulfur. So before that you have to know what do you mean by polymorphism. So what do you mean by polymorphism? So polymorphism, suppose a substance can exist in two different crystalline forms. One is crystalline form is A, another crystalline form is B. Okay, so these are two crystalline form, and these two crystalline form have different physical properties. So the definition of polymorphism is that the existence of a given substance in more than one crystalline form with different physical properties is known as polymorphism. And remember that polymorphism occurs in a number of elements and compounds also. So if you consider water is a compound. You can consider water as a molecule, and you know that water, if you increase the pressure of ice can exist in different crystalline form. It can exist in 7 different crystalline form. So all are polymorphism of water. Similarly, if you consider sulfur can exist in two different polymorphic form. One is rhombic sulfur and one is monoclinic sulphur. So these are polymorphism. Now if you consider allotropy is different. Remember, allotropy occurs only for elements. That means if you consider carbon, sulfur, that are the elements. So you can consider that diamond, graphite, that are all are allotropes of carbon. Similarly, if you consider monoclinic sulphur, rhombic sulphur, these are also allotropes of sulfur. But as I told you that polymorphism occurs for elements and also for compounds. Okay, so that means if you consider monoclinic sulphur, rhombic sulphur, these two forms of sulphur are also allotropes of sulphur and also polymorphs of sulphur. But if you consider water, that is 7 different crystalline form of water are only polymorphs of water. They are not the allotropes of water. Okay, so this is the difference between polymorphs and allotropes. Okay, that means polymorphs occurs for elements and also for compounds. But if you consider allotropes, that occurs only for elements, that is not for compounds. Okay, so now if you consider sulfur, as I told you that sulfur can exist in two different forms. One is monoclinic sulfur and another one is rhombic sulfur. Now suppose this is a SR, that is a rhombic sulfur. So if you heat the rhombic sulfur under the pressure of 1 atmosphere, it changes into monoclinic sulfur at almost 95.6 degrees Celsius. So this temperature at which one polymorphs converts to another polymorphs is called transition temperature. Okay, so transition temperature for sulfur is 95.6 degrees Celsius. Alternatively, you can say that if you cool down the temperature of monoclinic sulfur, now you have to draw the phase diagram of sulfur. Okay, so phase diagram of sulfur. So as I told you that sulfur can exist in 4 phases. Number one is rhombic sulfur, RHOMBIC, rhombic sulfur. Number 2, monoclinic sulphur. Number 3, liquid sulphur and sulphur vapor. So sulphur liquid, and number 4, sulphur vapor. So these are 4 different phases of sulphur. Now, before drawing the phase diagram of sulphur, you know that in a phase diagram you have to know, number 1, you have to know the curves. What are the curves present in a phase diagram? Number 2, you have to know the triple point. You have to know the triple point. And number 3, you have to know area. So these are 3 important part of phase diagram. You have to know the curves, you have to know the triple points, and you have to know the area. So now, before that, you know the degree of freedom, F is equal to C minus P plus 2. So that is the degree of freedom. Now if you can see here, sulphur can exist in 4 different forms. Okay, so now you can say that okay, in that case you can say the number of phase is equal to 4. So if it is 4, it is a 1 component system, so 4 phase plus 2, so minus 1. So degree of freedom is equal to minus 1. That is not possible. So from that equation you can conclude that the 4 phases of sulphur cannot coexist. Okay, only you can say that 3 phases can exist. 3 phases can exist, but 4 phases cannot coexist in a particular point. Okay, only 3 phases can exist. So now you have to draw phase diagram of sulphur. So in the phase diagram of sulphur, like before, the y-axis is pressure and the x-axis is temperature. So this side is temperature and this side is pressure. Okay, now you have to start. Suppose you have to start from a point. So suppose this is a point. So this point you start from here, and here the temperature is almost 50 degree Celsius. So it ends, suppose you start from A, it ends at O. After O you can get another curve and it ends at B point. After B point you can get another curve. So as I told you before, that at lower temperature, that means the temperature below 95.5 degrees Celsius, rhombic sulphur is stable form of sulphur. So you can see here a transition of sulphur occurs. So this is 95.5 degree Celsius. So here the transition of rhombic sulphur between converts to monoclinic sulphur. So here, like before, SR, that is the solid form, of sulphur, rhombic sulphur, that is in equilibrium with what? Vapor. Okay, so here rhombic sulphur is in equilibrium with vapor. So this is the sublimation curve of rhombic sulphur. So here you can write, this is the sublimation curve of SR, rhombic sulphur. Now here you can see it converts to monoclinic sulphur. So if it converts to monoclinic sulphur, here you can see this is the sublimation curve of monoclinic sulphur. So this is the sublimation curve of SM, monoclinic sulphur. Okay, so after that point you can see this is the next point, B point. So here at the B point, melting of monoclinic sulphur occurs and it is almost 120 degree Celsius. Okay, it is almost 120 degrees Celsius, and almost the pressure at that point is almost 0.025 millimeter of Hg, almost 0.025 millimeter of Hg. And at that point it is almost very small pressure, it is almost 0.01 millimeter of Hg. Okay, so here the melting of monoclinic sulfur occurs. That means here sulfur converts to liquid sulfur. So after that point, liquid is in equilibrium with vapor. So liquid sulfur is in equilibrium with vapor. So you can see the three curves, 1, 2, 3. The first curve, this is the sublimation curve of rhombic sulfur, because as I know that below 95.5 degrees Celsius, rhombic sulfur is a stable allotrope of sulfur, polymorphs of sulfur. So here the transition of monoclinic sulfur occurs, transition of rhombic sulfur occurs here and converts to monoclinic sulfur. So this is the sublimation curve of monoclinic sulfur, and this is the liquid is in equilibrium with vapor. Now here you can see rhombic sulfur transforms to monoclinic sulfur. So here you can see, you can get another line like this, and suppose it continues here. So this is the another line. So here as two allotropes are equilibrium, so you can say here that SR is in equilibrium with SM, monoclinic sulfur. So rhombic sulfur is in equilibrium monoclinic sulfur through this line, and you can see this line having a positive slope. Positive slope means if you increase the pressure, the transition temperature gradually increases. Okay, transition temperature gradually increases. So this is not a melting point, this is a transition point. So if you increase the pressure, the transition temperature gradually increases. Now here you can see the melting of monoclinic sulfur occurs. So what I can say, you can get a line also, and this line meets at that point. So you can get another line here. So here monoclinic sulfur is in equilibrium with liquid sulfur. So here the melting point occurs, melting of monoclinic sulfur occurs. So you can see this is a positive slope. Positive slope means if you increase the pressure, the melting point of monoclinic sulfur increases. Okay, so this is the another line. So these all are solid lines. In the first solid line you can see rhombic sulfur is in equilibrium with vapor, and you can see here also that if you decrease the temperature from O point, gradually it converts to A point. So below A point the line does not exist. Why it does not exist? Because after that point you cannot able to measure what is the pressure. Okay, that's why this is the starting point. The starting point is from 50 degrees Celsius and it ends at 95.5 degrees Celsius. In the next curve, next line, the monoclinic line, here it starts from 95.5 degrees Celsius, ends at 120 degrees Celsius. So now you can see another point here. So suppose the point, this point is B point, this point is C point, and suppose this point is D point. So at D point you can get a temperature also, and that temperature is almost 155 degrees Celsius. So this is 155 degree Celsius. Okay, 155 degrees Celsius, and the pressure is almost pressure is very high. Here the pressure is 1290 pressure. Okay, so the pressure is very high. It's almost 1290 atmosphere pressure. So now it is not a millimeter of Hg, it is almost 1290 atmosphere pressure, very high pressure, because all the forms are solid form now. Now come here. So what you can get here? So first, rhombic sulfur is in equilibrium with vapor. So you can say this area is for rhombic sulfur. Rhombic sulfur, that means SR. This area here actually you can see the rhombic converts to monoclinic. So this area is for monoclinic sulphur. Monoclinic sulphur. And you can see here the liquid sulphur converts to liquid, solid sulphur converts to liquid. So all are liquid. And here in the very low pressure region and high temperature region, very low pressure and high temperature region, all are vapor phase of sulphur. So you can see total 4 area. Here this is the all are vapor phase. Here all are a liquid phase. Here all are monoclinic sulphur, and here all are rhombic sulphur. Okay. So now at that point you have to know what is the metastable equilibrium. Okay. So metastable equilibrium, that means first you have to see the OA curve. Okay. So if heating is done very rapidly, then it is possible to heat rhombic sulphur above transition temperature along OE point. So if heating is done very rapidly, that means if heating is done, then you can get a dotted line like this, and you can get up to E point. So this point is E point. So if heating is done very rapidly, then you can get this dotted line. So this dotted line is called metastable line of rhombic sulphur. So here in the dotted line also rhombic sulphur is in equilibrium with vapor. So this is actually the sublimation curve of rhombic sulphur. Okay. Now at that point you can see the melting of rhombic sulphur occurs. So after that it converts to liquid, and it will again you can see a dotted line that will go through this BC line. Okay. So here actually the rhombic sulphur converts to liquid, and this is the liquid vapor equilibrium. Now at that point melting solid converts to liquid. So if you get a line like this, again there is a dotted line, it will meet at D point. So actually here the dotted line, this is another metastable equilibrium, and the metastable equilibrium actually SR, solid rhombic sulphur, is in equilibrium with liquid. This is the another metastable equilibrium. A rhombic sulphur is in equilibrium with liquid. So here you can see first this is the metastable equilibrium. Here rhombic sulphur is in equilibrium with vapor. Here melting of rhombic sulphur occurs, rhombic sulphur converts to liquid, and this is the melting point curve of rhombic sulphur. And in that point in the dotted line you can say that the solid is converted to liquid. So this is a liquid vapor equilibrium extended line. So these three dotted lines that all are metastable equilibrium. Now if you see here, if you slightly disturb it, then this line actually merges with the curve OA, which is the vapor pressure curve of monoclinic sulphur. So slightly disturbing the line, it will merge with this line. So that's why these are all the metastable equilibrium. But now after D point, actually this dotted line becomes stable, and after D line you can get a solid line. This dotted line now becomes a solid line after D point. So here actually this is also rhombic sulphur is in equilibrium with liquid. That means at very high pressure there is no monoclinic sulphur, all are rhombic sulphur. So here all are rhombic sulphur. Only in this small region, very small region, monoclinic sulphur exists. But here all are rhombic sulphur. Now you have to know what is the degree of freedom of different curves of different points and areas. So here you can see this solid rhombic sulphur is equilibrium with vapor, so two phases are equilibrium. So in that line the degree of freedom, like before, it is also F is equal to 1. Here also two phases are equilibrium, that means monoclinic sulphur is in equilibrium with vapor, so sublimation curve of SM is in equilibrium with vapor. So here also F is equal to 1, Here liquid sulfur is in equilibrium with vapor, also F is equal to 1. Here Sm, in that line Sm, liquid monoclinic sulfur is in equilibrium with liquid, so here also F is equal to 1. And here two solid form of sulfur that are equilibrium, so here also F is equal to 1. Now if you see the area, here is this is the one area, and in that area F is equal to 2, because this is only one phase is present. And now in that phase F is equal to also 2, and in that phase F is equal to also 2, and in that in a small region, the monoclinic sulfur region, here also F is equal to 2. So these are the four areas in the different areas, or in all cases degree of freedom F is equal to 2. Now you have to know another important thing, that is the tipple point. So here you can see there are mainly three tipple point. One is here, first tipple point, second tipple point at B point, and another, this is the another tipple point, that is the D point. So in the O tipple point you can see three phases are equilibrium. What are those phases? Rhombic sulfur, monoclinic sulfur, and vapor sulfur. So three phases are equilibrium: rhombic, monoclinic, vapor. So here degree of freedom F is equal to 0. Here degree of freedom F is equal to 0 at the point. Here also you can see monoclinic sulfur converts to liquid. So monoclinic sulfur, liquid sulfur, and vapor sulfur, these three phases are equilibrium. So here also F is equal to 0. Okay, and this is the another tipple point. Here you can see the rhombic sulfur is in equilibrium with liquid, and that is in equilibrium with monoclinic sulfur. So that means here also degree of freedom F is equal to 0. Okay, so these are the three tipple points. In all cases the degree of freedom F is equal to 0, and I already told you before that the four phases cannot coexist in equilibrium, because in that case the degree of freedom will be -1. That means this is because that means that four phases cannot be in equilibrium. That means four phases cannot coexist in equilibrium. So what I can conclude, that three or fewer number of phases for one component system can exist together, can exist in equilibrium. Okay, so this is the phase diagram of sulfur. Thank you. Finally, my request to my students, please subscribe my channel. Thank you.